The following conversation with Professor Roger Seifried, a distinguished figure in the field of electrical engineering with a storied career spanning academia, industry, and consulting. Educated at the University of Cincinnati, where he earned his PhD, master's, and bachelor's in electrical engineering, Professor Seifried has dedicated his life to advancing the field through both theory and application. His academic journey has seen him as visiting assistant professor at Miami University and an adjunct professor at both Central State University and Cincinnati State Community College. Beyond the academia, Professor Seifried has a rich history in the industry, having contributed significantly to Cincinnati Millicron in various capacities, from design engineer to government systems manager, where he was instrumental in pioneering advancements in machine tool research and deployment. His consulting work has impacted numerous organizations, helping them navigate the complexities of manufacturing and technology. In our conversation, we delve into the depths of electrical engineering, exploring the intricate relationship between theoretical principles and their practical applications. Professor Seifried, with his wealth of experience, provides unique insights into the evolution of the field, the challenges it faces today, and the future it is heading towards. I am here to explore this mysterious world, seeking to understand its every aspect and detail. My quest is fueled by an insatiable curiosity about every idea, thought, and decision. Through long and complex conversations with some of the brightest minds like Professor Seifried, I aim to inch closer to the truth, unrevealing the tapestry of knowledge that binds us all. Join us as we embark on this journey of discovery where the realms of electrical engineering and human ingenuity intersect. You've been in this field from the time of before 1990s, right? So there was a huge change.
Yeah, definitely a huge change. When I went to college, and particularly with computers, we did not have handheld calculators. We did not have individual computers. There was one computer on campus, and we had to take our program over, give it to them. They'd run it overnight, give it back to us the next day, and it had to be punched on punch cards. So it was a key punch machine, like a typewriter, would punch holes in the punch cards. And the punch cards would go over and be read into the computer, and the computer would do its thing. I believe it was a IBM 1620. And
do you remember what year was it?
What year? This would have been about early 60s, 62, 3, 4, long there. Yeah. And all our calculations were done with slide rules. Okay?
Which one?
A slide rule.
Okay.
Not sure what a slide rule is.
I don't think so.
You young folks don't know what a slide rule is. Yeah, you can do all kinds of things with a slide rule. I don't remember how anymore.
Okay.
But anything except adding and subtracting. So if you had to add a whole bunch of numbers together, that was no good. And of course we didn't have handheld calculators at that time.
Yeah.
So things have really changed. The desktops that we have today are way more powerful than the university's computer was back in those days.
Yeah.
And
Everybody has it.
well, if I remember right, there was a big panel on the side of the computer, and there were jumper wires in the panel, and you had different sets of jumper wires to plug into the computer to make it do different things. It was a big thing.
Yeah, I imagine at that time computers were like one room sized computers.
Well, yeah. Later on, then they got well. Back before that,
Mm-hmm.
when the first computers were made out of vacuum tubes,
Okay.
I wasn't part of that. But yeah,
So you made the computers from vacuum tube?
vacuum tubes. The whole computer was made out of vacuum tubes, and vacuum tubes are a little smaller than your fist,
Okay.
and compared to a transistor, which is about as big as your small fingernail. And then when they're on integrated circuits, you can get thousands and millions of them on an integrated circuit today. So the computer that had millions of transistors on it today would have millions of vacuum tubes.
Yeah.
And of course it wasn't that capable, but yeah, fill the whole room.
So vacuum tube, it looks like how I seen in a pictures, in a videos. It looks like a lamp, right? It's just like a ordinary, like old school lamp, and it consumes a lot of electricity, right?
Yeah, well, the servers today consume a lot of electricity too,
Mm.
but they're doing a whole lot more.
Yeah.
Okay. From an electronics standpoint, radios and televisions were made out of vacuum tubes, with vacuum tubes. And it was interesting. Most every drugstore had a vacuum tube tester. And you go into you call them pharmacies today, but
Okay.
drugstores. And if your television quit or your radio quit, you pull the tubes out, take them to the vacuum tube tester, plug them in, they would test them, and the bad ones, and you buy new ones, put them in. Okay.
Yeah.
So
So these vacuum tubes were that demanded that even drugstores used to sell them. So because all electronics were made by vacuum tubes, right?
yeah, electronics was all vacuum tubes in those days.
It's so fun. It's actually really interesting how huge were the changes, because even before that, let's so changes were started I think from 1980s, and it's continuing until now. So it started with, I think, a lamp, just ordinary lamp, and diode, and after that diode became transistors.
Oh yeah,
Yes.
yeah.
Then after transistors, they started inventing chips. So chips invented computers. So computers now inventing AI.
When I was in college in the early 60s, transistors were just becoming available. And we did have some transistor labs, and we didn't do much with the transistors. We analyzed the transistor itself rather than using the transistor to make circuits. But yeah.
It's really interesting because current average computer chips made by, for example, Intel, this company creates a little computer chips, and this chips usually contains more than billion transistors.
Yes.
And it's really hard to imagine how they put into like small chip, like 2-inch to 2-inch like chip, and there are like billions of transistors inside it. It's fantastic.
Yeah. The old vacuum tubes looks kind of like upside down test tubes, clear test tubes.
Yeah.
Yeah, and then inside that was a grid and a cathode and by controlling the voltage I'm trying to remember now, I studied them in college. By controlling the voltage on the grid, you could determine whether the electrons were going to flow through the vacuum tube.
Through the vacuum tube. Yeah. And also, I somehow remember that I've seen or I've read something which says before computers, there were also mechanical computers, which was so loud, right?
Yeah.
They could calculate stuff, but they were so loud that like is something like that.
Well, they weren't too loud, but they were loud. Yeah, they made a lot of racket. And adding machines, everybody back in those days had an adding machine. Punch the buttons on the adding machine, pull the lever, punch the buttons, pull the lever.
Okay.
And it was all mechanical.
It's like calculators, but like old school calculators, right? It only did adding and subtracting, or multiplication also.
In what, the calculators?
In adding machine, which you told.
Oh, adding machines.
Yes.
Well, they kept getting more and more sophisticated and eventually became calculators. Okay. But yeah, I never really used them much, so I don't remember the details of the adding machines.
Yeah. So I think even in an engineering field, the instruments which engineers use dramatically changed. I mean, from starting with adding machines, rulers, or even like paper, computer came there and changed the whole tool set, I think.
Yeah.
Right?
When I first started working designing NC controls, the company I started for already had NC controls made out of little bitty relays that they called flux modules. Okay. They were little bitty tubes with a coil around them, and you run current through the coil would cause them to open and close, all right? And that was right before digital logic came out in a semiconductor form.
Okay.
And then the next control that they designed was with digital logic. And when I got there, I was designing controls using the next generation of digital logic. But at that time, all we had were shift registers and gates and flip-flops. You couldn't buy a counter, or you couldn't buy an adder or any of that kind of stuff, okay? Yeah. An ALU, arithmetic logic unit, no, that didn't come on until a lot later. And back in those days, PCs existed at that time, but they were too slow to run a machine tool to do the calculations necessary to calculate the path of the tool Okay. And about the time I left that area, they were starting to come out with embedded computers. Computers had started getting faster. And as a matter of fact, I remember using one of the computers, playing with it, and to start it up, you had to punch a bunch of numbers, hit enter, binary number, another binary number, enter, binary number, enter. Did that enough times, I put in the startup program to start up the computer. And back in those days, we were using the Motorola chips. And here, when I first started 20 years ago, we were using the Motorola chips here. Motorola still makes them. They keep improving them, of course.
Yeah. And I think by the time there wasn't any people who are called computer scientists. Before there were only engineers. Like
right.
Even
right.
computers were made by engineers. Even let's say like programs were made by engineers, because programmers wasn't any kind of like digital object. It was like mechanical object. I mean, you program computer by just putting details in it. I mean, transistors, like resistors, like forming some kind of chips, and there wasn't anything which is called software. It was just pure hardware. Just collect computers, I mean chips, and combine chips and make some stuff which works, right? But now after I guess after 1980s or after 1990s, the thing which is called software became more popular, and people start to make softwares, create softwares.
Yes.
And
that
people
became
which are called software engineers became more and more popular.
That became a field to itself. We were, when I went to college, electrical engineering, you had an option of going into power, motors, that type of thing, or computers. They just started that.
Yeah. And you choose computers, right?
I chose computers. Yeah.
Of course, that's good. That's great.
Most people did when I was there.
Yeah, because I guess at that time computers were a thing which is currently AI. AI is becoming more and more popular right now. At that time it was computers. Like computers became...
We could see them as a coming thing.
Yeah.
Where motors had been around quite a while.
What do you think? Was it hard to get started with computers at that time? Was it complicated to learn computers? Because currently people say AI is hard, right? What about that time? Was it complicated at that time?
Well, if you had the interest and the knack for it, just like anything else, it's not hard.
Yeah.
So what you and I do here at school would be very hard for a lot of people. And I'm sure that things that they can do very well would be very hard for us to do.
Yeah.
No, it wasn't hard at the time. We learned at that time. We learned about flip-flops and so on, and of course the flip-flops were made out of transistors.
Yeah.
As we studied them, there weren't chips that were flip-flops even.
Let's see. That's great. So, in a realm of, like, in a world of electrical engineering, there are often moments of sudden insights, insight or clarity. Like, Could you share such moment from from your career, from your path, that significantly shaped your research or teaching philosophy?
Research or teaching philosophies,
Yeah.
as opposed to electrical components.
Electrical engineering, yeah. Like there might be some insight or knowledge which you gained, which is like significantly shaped. Maybe.
From a teaching standpoint, we teach here circuit analysis, DC circuit analysis, AC circuit analysis,
Mm-hmm.
same as I learned. What was it? 70 years ago.
Okay.
Okay. The only difference is you can use a calculator now instead of a slide rule. But the theory is all the same.
Yeah.
The theory for digital logic, pretty much the same.
Yeah.
The components, what's really changed is the ability to integrate all the components on a given chip.
Mm-hmm.
Okay. So yeah, the idea of a shift register, whether it's made out of relays or whether it's made out of gates and flip-flops or whatever it's made out of, is the same idea.
Mm-hmm.
Okay.
Because it's maybe basically a physics.
I don't know. It's based in physics. It's just a tool that's used in manipulating numbers,
Mm-hmm.
and manipulating numbers is what we do. Now, those numbers might represent letters, and the letters might represent books, and so on. But as far as the computer's concerned, it's manipulating numbers,
Mm-hmm.
binary numbers in particular.
Yeah. Just getting some numbers as a current, as a other type of things, and manipulating them, getting input, giving output from it.
Yeah, the input devices changed quite a bit. I was working on my PhD thesis. The way to use a computer was to call it up on a telephone. But the telephone receiver and a modem, and it would beep at you, and beep, 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 beep.
Mm-hmm.
And then you would type on a typewriter. Okay? And that would be your keyboard, a typewriter.
Okay.
And the paper coming out of it would be your display. Okay?
Yeah.
And even before that, I worked on an interface between a computer and a teletype machine.
Okay.
And we used the teletype machine because it had a keyboard and had the ability. You couldn't buy keyboards in those days,
Mm-hmm.
other than a Selectric typewriter, that type of thing.
Yeah.
But yeah,
Like tick, tick, tick,
electric.
tick, tick, tick.
Actually, electric typewriters were available back then, or they're available back then. Of course, before that,
Okay.
you push a key and an arm would come up and strike a number.
Yeah, like
You push a
mechanical
key
one.
and an arm would come up and strike another letter, okay?
I see.
And my dad had one of those.
Yeah.
Now I forget where I was.
So you were working on connecting electrical.
Oh,
Yes.
yeah, the teletype machine.
Yeah.
And the teletype machine runs serial.
Yeah.
Very much like the internet. Okay, it's not all that different from the internet and so on. Series of digital pulses, and 8 pulses make a byte.
Yeah.
And they're collected at the other end, all right? And part of my job was to do an interface to convert the serial pulses and the start and the stop bits and so on to bytes of data to feed into the computer, because the computer worked on parallel bytes of data.
Yeah. So it's like encrypting data as a byte and getting these bytes from other end and decrypting this byte into human language. Am I right?
No, well, the way you said it, no, but what you meant, maybe what you meant was right. The individual byte would mean a letter. So as we sent, back in those days, we sent information across the country on teletype. Okay, you get a telegram.
I see.
That's how you got information across the country.
I see. Okay.
And it would come through the wire to the teletype machine here, from New York to here, print out here, and a guy on a bicycle would run out and deliver it to you. Okay.
I see.
So it was exciting back in those days to get a telegram.
So it was the quickest way to get the messages, right?
Yeah.
So,
as a matter of fact, radio announcers were announcing baseball games. In the early days, and when I was young, I didn't realize this, but when there was a teletype machine that was sending the information to the broadcaster, who we had AM radio at the time, and the broadcaster would read it and try to make it interesting, as if he were calling the game, sitting there in front of it.
So the broadcaster just only read the telegram, which is coming from other broadcaster, which is typing the telegram?
Yeah, if our team played the team in Baltimore, at Baltimore, well, the information would be teletyped. They would have a connection, teletyped like a telephone connection.
Okay.
Teletyped, and he would read that information, and then he would kind of, the information would be so and so got a base hit. Well, what he would do is make up, a mighty swing, a line drive, out into the left field, and they're throwing it in, and he's safe at first,
That's crazy. Yeah.
So they would, it was neat, but yeah.
That's crazy. That's cool. Yeah, fantastic. That was really quick how everything has changed, how industry has changed, how messages, how sending things, because currently right now I'm sitting with you who have seen all of these things, and I cannot even imagine without you explaining it to me. Because before there wasn't any that kind of rapid changes, but from 1960s until now there were huge changes on everything, on the whole world, on every industry, on every life aspect.
And I'm guessing you're going to see the same amount of change through your life. I don't know. I don't know what's coming. Of course, AI is a big thing.
Yeah, it is.
Yeah.
It is. It's really cool. Oh boy.
Computers, I cannot yet see the end of what computers can do. Okay. There are jobs that were too big. Wasn't too long ago, weather forecasting by computer models couldn't be done 10, 20 years ago.
Yeah.
Now it can be done. We used to be happy if we get a forecast for the next day. And now you can get a forecast out 7 days, 9 days, 10 days. Not always accurate, but they weren't always accurate back then either.
That's cool.
It is amazing.
That's amazing.
It is.
Okay, so as someone who witnessed the evolution of electrical engineering and evolution of every aspect of technology, so how do you think the approach to teaching this subject should change in next, for example, decade?
Okay, how should teaching change? Well, there's a lot more to teach now. I teach a course on microcontrollers. We didn't have microcontrollers 20 years ago. We had microprocessors.
Mm-hmm.
Oh, okay. So the subjects are changing quite a bit in electrical and computer.
Mm-hmm.
I'm not into the radar and the transmission and that kind of stuff, but the digital transmission of information is also changing quite a bit, even over the air and over the wires and so on. I think probably the biggest change in teaching is happening now. And that is the ability to teach a class without the students being in their classroom. Mm-hmm. And I know they have done that earlier. Australia, for instance, did that quite a bit. But after the COVID here, we saw everybody kind of got used to the idea. Hey, I can learn just as well sitting at home looking at my computer, and I don't have to spend an hour and a half driving when I could be doing homework and learning. Mm-hmm. Okay? Now, there's pluses and minuses to that. The plus is, of course, what I just mentioned, okay? And another plus is that what we're doing here at this school, and not many schools do that, is that we are broadcasting our courses to other colleges, okay? There, in this country, there are community colleges, which are 2-year colleges. There are 4-year schools. What we've done is made a program that is the second 2 years of a 4-year degree. And the community colleges are spread all over the state, and the students are close to them and have access to them. They can go in and do their labs there and so on. They don't have to drive 50 or 100 miles every night to a big 4-year institution, okay? That is changing. Even that model is changing.
Yeah.
because the students can stay at home.
Mm-hmm.
They don't have to go into their community college, except our program is hands-on,
Mm-hmm.
work with electronic components and so on.
Mm-hmm.
So either they have to have them at home. They're not too expensive, but they cost some money. Not the components, but the meters and that, and the scopes and that kind of thing are a little bit expensive.
Mm-hmm.
Yeah, but the ability to anything that doesn't have hands-on and history.
Mm-hmm.
You don't need to be in a classroom to learn history. You don't need to be in a classroom to learn language. Only engineering, even programming.
Mm-hmm.
You don't have to be there,
Mm-hmm.
because you can show your programming screen to the professor who is probably sitting at home in his underwear teaching the class. Okay. And he can look at your software and help you debug it and so on. It's no different from being there.
Yeah. That's right.
You can afford, and I think it's all going to, I eventually think it's all going to go that way. And I think professors are going to, we won't need as many professors, let's put it that way.
Hmm.
We will have excellent master professors who record their courses.
Mm-hmm.
And for circuit analysis, it doesn't change over the years. Get the best professor to give the best lecture and use that guy for everybody, for every school. Okay? And that puts me out of a job.
No.
Because I'm probably not the best professor for anything. It's going to put some of us out of a job.
Mm-hmm.
It won't put me out of a job. I'll be retired by then.
Yeah.
But yeah, I think that's the biggest change is the ability to work online, to learn online,
Mm-hmm.
to record lectures, to record explanations. If I want to fix something, first thing I do is I don't know how it works. It's some gadget. I get online. First thing you know, there's 4 or 5 videos on how to fix it.
Mm-hmm. Yeah, for sure. Videos, digital media, even audios, even textbooks all around the world. You can find any source, you can find any content.
And if you're the least bit handy with a screwdriver and a wrench and so on, you can do the mechanical things. And least bit handy with a soldering iron and a couple meters.
Like take out everything from car and put it back. Like yeah, but what do you think about AI? The most advanced, the most powerful AI is ChatGPT, and how I heard from so many professors, they're saying actually ChatGPT impacted the courses and I don't know, like exams or maybe like lectures or any other part of it. So most of schools banned ChatGPT and that kind of AI chatbots. What do you think? How it impacted exactly? Maybe your courses, maybe.
How's AI affecting courses?
Engineering overall.
At the moment, I don't see it affecting engineering courses much.
Mm-hmm.
I certainly see it affecting courses where you have to write a paper.
Mm-hmm.
write a paper on this subject, I'll write a paper on that subject. The AI machines today can write the paper for you. Mm-hmm. Okay? It's a good thing because I was never very good at writing papers. Right?
Yeah.
But it's not AI so much as it is how many different kinds of problems can you think up to put on a test about a particular subject? There aren't that many different kinds of problems, really. Mm-hmm. Okay? Ohm's law or Kirchhoff's voltage law. Mm-hmm. How many different problems can you... Well, somebody's probably solved them all already and published them on the internet. So cheating is a problem for the students because they don't learn. They think they can find everything on the internet, and maybe they can. And if they can, they don't need to come to school. So the ability to design amplifiers, that was a big deal. Different kinds of amplifiers. And you go and you buy an amplifier. You don't design an amplifier. You go buy one and then do what you want with it.
Yeah, for sure. Yeah, I also think it's not much to do with engineering using AI, because it's more about practical work.
Yeah.
You need to make stuff. But one more thing which also made me kind of, when I first came to university, American university, the point of view of students, point of view about cheating. Not many students there tend to cheat. They don't think cheating is good, and from their inside.
Mm-hmm.
How is that? How it's possible to achieve? Because I also study in, for example, Europe, in Poland, or even with the Russian community and with other communities. I'm not specifically saying Russians or other communities bad, but like in other places, university, schools, cheating is kind of like normal thing.
Yeah.
But in this community, I have noticed that cheating is not accepted at all. So how to achieve that? Why?
Well, let's see. I don't see much cheating other than on homework and labs, because the student can take the lab home and call their friend or get a copy of lab's pretty much the same. Get a copy of a lab from last year and copy it. We used to do that too back when I was in college. Okay, we had files at the fraternity full of the tests and so on. Now the tests weren't always the same, but it helped you if you went over a test before. Okay, I don't call that cheating, going over an earlier test. Your degree will get you a job. Your knowledge and abilities will get you to keep the job and progress in the job. Some students are here to get a degree.
Mm-hmm.
Some students are here to learn the material. And of course, a bunch of them are a combination of that. And I find that the older students, the students who have gone out into industry and then come back, they don't care so much about their grades. They care. They care about learning the material.
Mm-hmm.
And the younger students, they care more about their grades than they do about learning stuff.
Mm-hmm.
So cheating, yeah, fits in there.
Mm-hmm. I see. It's more than childish decision than the.
Well, then what?
It's something like childish decision for them. Just like.
Yeah.
Keep something like, good job, great, like I got really good marks, but
Oh,
in
yeah.
reality,
Yeah.
it doesn't help much.
Right. Yeah. And of course, when you get old, you look back on it and you say, yeah. Now I understand what I should have been doing.
Mm-hmm.
Now I understand how I should have studied more, how I should have paid attention to the bigger picture than the individual calculations.
Mm-hmm.
Why am I doing this? What good is it? Another thing I learned after I got out of college is to take a look at the text that's going to be presented before you go to class. Just look at it. Oh, I wonder what that is. Oh, I wonder what that is. You get into class, you've at least heard it before, and you pay a lot of attention. I used to go to sleep. I hear new things that were going on, and I get lost. First thing in, I'm sleeping. Well, it doesn't do me any good. But if they talked about something I had heard of before, even though if I didn't know what it was,
Mm-hmm.
I paid better attention. Interesting.
It is. How do you see artificial intelligence will transform field of electrical engineering in next years?
The answer is I don't know.
Yeah. So.
You could use AI to design things.
Mm-hmm.
Okay. You could use AI to optimize things.
Mm-hmm.
It's a terrible problem to figure out how to put the millions of transistors onto a chip, where to put each one, and how to interconnect them all.
Mm-hmm.
There used to be a problem they called the traveling salesman problem. And that was how to optimize his route to his various customers. Should go to this customer and then that, and then over here, or should go here and then there and there.
Mm.
Okay, and there were methods to optimize that, and optimizing things, I think AI could probably be used for.
Mm-hmm.
I would think.
Yeah.
It may already be being used for it.
Yeah,
I don't know.
Mm-hmm.
All right.
So, also, as someone deeply immersed in engineering and technology, how do you preserve the role of art, music, and culture in shaping creative innovation or thinking in your field?
Okay, art and music and all that kind of stuff. I was never much interested in art. It's your interest, I think. I wouldn't go to an art museum for anything.
Mm-hmm.
When I got older, it was kind of neat to go into some of the churches and buildings in Europe
Mm-hmm.
and see what was built and what the Romans had built back in the old days and that type of stuff. Music, I like music. I like rock and roll. I don't like symphony music.
Really? You
Yeah.
listen to rock and roll?
Yeah. I grew up when rock and roll started. Rock and roll started in in the 50s. I'm trying to remember. It really started catching on around 54, 55.
Mm-hmm.
And at that time, the very first transistor radios were coming out. And people were all walking around with little transistor radios and a plug in their ear listening to rock and roll music on an AM station. There weren't any FM stations.
I think I only know from old school rock and roll is AC/DC.
I think they were a rock group, yeah.
Yeah, it was a rock group,
Yeah.
and I think it was on 90s, if I'm not mistaken.
Yeah.
90s or 90, yeah, something
I
like that.
grew up with Elvis Presley.
Elvis Presley, yeah. I know
Yeah.
him.
He came on a little later. But the first one, there was two kinds of music, doo-wop and rock and roll. And a doo-wop was a lot of, I don't even know how to explain it. My son's into music, so he could explain it. Rock and roll was a lot of banging and jumping around kind of stuff. Doo-wop was a little slower, and a lot of melody and a lot of things going on in the background of the music. Yeah, taking me back to when I was in high school.
Yeah, that's awesome.
Yeah.
So, about the high school, or just like school overall, the concept of mentorship is crucial in academia, in professional growth, in high school or schools. So, could you share the story about the mentor who profoundly influenced you, influenced your path, and what was the most valuable wisdom you gained from them?
Yeah. I didn't have a specific mentor, but when I was in high school, there were two courses, chemistry and physics, and particularly physics, really interested me.
Physics.
Yeah.
Okay.
And the physics teacher, I asked him, I think I'll be an engineer. I'm not sure what an engineer is, but I think I'll go to engineering school. I asked him, which do you think will be the hardest? Electrical or mechanical or nuclear? And he said, probably electrical. Okay, that's what I'll take.
Oh, okay. Yeah.
I had confidence in myself back then.
It's really
And
course actually. Fantastic. I wish I choose the field that will go that way.
yeah. I didn't have a specific mentor. My father delivered mail.
Yeah. Yes.
He was a postman. So, and my family had no college. My dad took a couple college courses at a community college.
Mm-hmm.
But other than that, I was the first
person who got
first person to go to college.
higher education.
Yeah. In the family, and the extended family as well. Now, I think some of my cousins went to college. But my father's brothers and sisters, I don't think any of them went to college. I'm not sure.
I see. Yeah. So, we've talked about the past. We've talked about how it changed from past, and looking towards to the future. Amidst rapid technological advancements and AI integration, what's your greatest hope for humanity's relationship with technology, and what's your greatest concern?
I don't know about a greatest hope, but I wonder sometimes, back in time, at the time of the Industrial Revolution, machines are going to make everything. What will humans do? What are we going to do with all the people that used to make things, and all the machines are making them? Transfer lines made machinery, made cars, okay? Was never a problem. That was all new stuff coming along. Now, computers and AI are going to replace a lot of people. A lot of people that we tend to call clerks. The people who serve you at McDonald's and places like that. Eventually, McDonald's can become automated. And you probably won't even go in. You get on your phone and say, I want a Big Mac with fries. All right, I make the Big Mac with fries. You drive around the back and you pick it up. Well, it's almost that way today. Mm-hmm. Okay. This business with companies being able to ship things to you is making a big difference. And I'm just getting used to it. I'm old, and it takes me a little while to learn new things, okay? But the idea of Amazon, I don't go to stores anymore. I buy everything on Amazon. Yeah. And it shows up on my doorstep the next day. So instead of driving to this store, they don't have what I want, and then drive to that store, they don't have what I want. That's putting what they call brick and mortar stores out of business. Mm-hmm. Okay?
Whew. So, were there hopes or concerns?
That's, what are my hopes? What I would hope is that there's some way, and I don't know how, to avoid all the fighting that goes on in this world. And I mean actual hot wars, as well as you get our government. It's one side against the other. Mm-hmm. And to try to get anything done for the people in general is tough.
Mm-hmm.
We're going to get our way or we're going to shut down the government. Okay, well, that's not good. What's best for the people? Well, unfortunately, some people think this is best for the people and some people think that is best for the people. So a way for us to, shall we say, all get along is something that would really be great. And it has been in this country pretty much compared to other countries, certainly compared to many other countries, put it that way. Mm-hmm. Canada is the same way. You go to not Montreal. What's the other big city?
What?
Toronto. Yeah. You go to Toronto, it's a mix of people from all different countries. Mm-hmm. And so is New York, and so is Los Angeles. Cincinnati it's starting to get that way. When I was a kid, I never went to a grocery store and saw people dressed with headscarves and or obviously from different countries. No. But we're getting that mix now, and for most part we get along. But now you're seeing, even today, it's coming to where there's more fighting than getting along. The Jews don't, in this country, the Jews don't like the Arabs and the Arabs don't like the Jews. Okay? It used to be that the white people kept the black people down. I can remember going to Florida, stopped at a gas station. There were 2 drinking fountains on the outside of the gas station. Mm-hmm. One's for colored and one's for white. Okay? And there were black neighborhoods and white neighborhoods. There still are black neighborhoods and white neighborhoods. There still are Chinese neighborhoods and Indian neighborhoods and Somalian neighborhoods and so on. And I think that's great. Nothing wrong with that. Let's just not fight about it.
Yeah.
Yeah, you go to San Francisco, there's a big old Chinatown.
Yeah, it is.
Okay?
Mm, yeah.
It's just almost like I've never been to China, but I've been to Japan. Mm-hmm. But yeah, it's probably just like China.
Yeah, that's amazing.
And it's great. I think it's great. I love learning about other cultures. That's why I asked you different questions about your country, okay?
Yeah.
Another thing I find is interesting is religion. Mm-hmm. I'm a Christian. Oh, well, we are right. We are the right religion. No, I'm not so sure about that. Mm-hmm. Christians are only 20% of the world, I think. Mm-hmm. So, what about all the rest of those guys? And
yeah.
I don't know. I wonder about religion sometimes. I'm getting philosophical now, but why am I in my religion. The reason I'm in my religion is because my parents were.
Mm-hmm.
That's why, not because my religion's, I found I did a study and found my religion to be the better one.
Mm-hmm.
No.
Mostly it's like that.
That's true of most everybody.
Yes. Mostly it's like that.
Yeah. I don't know. I don't know how computers are going to solve those problems. I don't know how any kind of technology is going to solve those kind of problems. It's actually adding to the problems now.
Mm-hmm.
The smartphones. You can organize your own riot on a smartphone. You can organize your own overthrow of the government.
Mm-hmm.
You saw that happening in the Middle East a number of years ago. All the governments were getting overthrown, and people using smartphones to get organized and overthrow them.
Yeah.
Yeah.
So information exchange in these days is so rapid.
Yeah.
You can, well, before I doubt that you had the ability to see news. For example, let's say in this Iran, for example, yeah, or China or any other countries. So it was impossible to know about that like months before or months after the situation. So you will have to wait some period of time to hear to get this news, I guess.
Oh yeah.
But right now, even after like 20 minutes
Yeah.
of some action, of something happened, you can know even after 5 minutes, even just
Yeah.
a couple minutes, like 2 or 3 minutes.
Well, this country had a civil war
Mm-hmm.
not too long ago. One of my great uncles fought in it
Mm-hmm.
in the Civil War, so it's not that long ago.
I see.
And maybe it wasn't the Civil War, maybe it was the Revolution from England.
Mm-hmm.
That it was over, the war was over, but the people in the other end of the country didn't know it, and they were still fighting for, I think, another year.
Oh my God. 1 year without knowing.
I don't know what the exact time was, but for a long time they continued fighting.
Yeah, that's horrible.
There were Japanese who were reported World War II, after the war was over. There were Japanese hiding in the woods, still thinking the war was going on, for long periods of time.
Yeah, it's horrible. Yeah, information exchange is too rapid, even with, especially with the social media. So right now we have Facebook, we have Instagram, or other types of social media. Even not media, but just average person can post something, and person from other place from Earth can easily read this,
Mm-hmm.
and information can be spreaded in like milliseconds.
Yeah. You and I could talk to each other back and forth to Uzbekistan
Yeah,
very quickly.
I think that's
Okay.
also one of the reasons why it's going too rapid.
Yeah. Another problem is all the misinformation that's out there on both sides. I mean, I'm kind of talking political stuff here in this country, but
misinformation of media.
Yeah, the information that's put out is that I happen to be a conservative, okay? Donald Trump is a racist.
Mm-hmm.
Donald Trump doesn't like black people. Donald Trump doesn't like Chinese people, only white people.
Mm-hmm.
They've been pushing that for I don't know how long, about the Republican Party, which I'm part of. And we do the same thing to them. I mean, I'm not saying I'm not saying we're any better. But, boy, if computers could detect the truth, that would be a revolution.
I think
I don't know whether that's going to ever happen, but if they could detect the truth and find a way to get it to the public, truth can be detected today, but doesn't always get to the public. Okay, our side will tell the truth about the bad things the other side does, but the other side doesn't listen to our side, so they never know. And the same is the other way around.
mm-hmm. The middleman which detects the truth. So
that would really be something.
I guess I know that kind of technology. It is community nodes by Elon Musk. So recently Elon Musk bought the platform Twitter, and he transformed Twitter to X. So in X, there's a one feature which is called community nodes. When you post something, community nodes will comment on it, and they will like put out the truth on every post.
Yeah, but what side are they on?
They are usually no side by its definition, but
That would be great if that were true.
yeah,
I don't know. I don't use Twitter. Okay.
yeah.
I just don't know.
So,
But that's great if that kind of thing is happening.
yeah. So how I know how it works is, the people who before disagreed with each other, if they agree in one point with each other, the people who were disagreed before, if they agree in one point right now about something, it will be commented on it. So it works that way.
Yeah. The trouble is, all the people in this country agree on this, I think, on the same general things.
Mm-hmm.
We want freedom.
Mm-hmm.
Okay? We want freedom to pursue our own religion. We want freedom to pursue our own jobs, to live where we want. All that kind of stuff. But then they get to fighting about details.
Yeah.
Right now, they want to put low-income housing in high-income neighborhoods in this community. And the high-income neighborhood people don't want all that riffraff walking down their streets.
Mm-hmm.
Yeah, they will say, yes, we should have freedom. They should have freedom to live wherever they want, except in our subdivision. So yeah, that kind of thing happens.
Okay. We actually went.
We're getting into philosophy and politics now, as opposed to
human nature,
yeah,
philosophy.
Right.
it was actually fun, and it fit about challenges and obstacles. About So you undoubtedly face challenges and obstacles while your career, while your academic road. So could you share a particular, particularly challenging moment or project and how you navigated it through it? So emphasizing the lessons learned.
How I navigated a project, or how I navigated tenure, or what?
So
I'm not sure what.
yeah, while your road on, let's say, about electrical engineering, right? So have you ever um, have you ever like faced challenges, obstacles, and what kind of obstacles were there
Uh,
while becoming electrical engineer?
they were more political obstacles.
Okay.
Political, I mean political within the company. I don't mean
I see.
like Republicans and Democrats were political. Okay? This guy wants to own this part of the manages, but this guy wants to manage that kind of part of the, and they have different opinions as to how things are to be done. And one time I designed an NC control. It went on the market, started selling. Our company decided not to make it anymore. The reason was because we had an operation in England, and they had come up with a similar control. If we kept using my control, the English operation was going to go out of business. And so, for kind of political purposes, the head guy didn't want to give up the British operation. Power. I'm in charge of all this.
So
yeah, I did run into that, actually.
so it's about
More than once.
company in Great Britain and company in the United States, and each of it has its own operation system, how I understood, right? And why it's connected between each other, why they would be collapsed.
Yeah, well, that was probably a fault of upper management who had control of both.
Okay.
Why did you let us both develop a control? And in this case, it was a lower end control, a lower cost control. Okay, why'd you let us both develop that? I don't know. It just, sometimes things happen. They were over there doing their thing, and we were here doing our thing. We were doing the best we could. They were doing the best they could. A lot of dumb things happen in this world.
Do you have
For
examples? You've said you have faced that kind of challenges more than once.
Oh yeah, yeah, yeah. I don't know that I have specific examples of it, but things were done not for what I thought were reasonable reasons. Okay? This is better than that. You're always going to pick between two ways to do something, or three or four ways to do something. The boss picks this way. You're sitting back here saying, yeah, technically I know that's the better way.
Mm-hmm.
You lose. You have to do it the boss's way.
Yeah.
Okay.
What do you think was the best way to deal with this kind of situations?
You can't always. Do your own politicking,
Mm-hmm.
which I didn't do very well.
Mm-hmm.
I had a boss one time who explained to me, you will do something good,
Okay.
and there it is. It explains itself. No, it doesn't. Because the rest of the people who don't know much about it don't know how good it is. You have to go out and spread the word and sell it.
Mm-hmm.
Okay? And I was not good at that. I did some of it, but I was not good at it. I was good at the technical part. Well, why is mine better than his? His will be accepted because his mother happens to be on the board of directors.
Mm.
That kind of thing.
I see. So.
And it's good competition, even, excuse me, even within a company. It would be good competition to set two teams to doing the same thing. And then start comparing what they did. And if you had an honest broker working it at the top and bringing it together, what you would wind up finding is the best parts of this design, the best parts of that design, both together, you really have something good.
Hmm. Yeah. But it's more about, how you said, monarchy, even. It's more about, I think it's more about money and selling of things. So the company.
Engineers don't sell.
Yeah.
As a matter of fact, our salesmen at the company, when they went out to talk to a customer,
Mm-hmm.
they wouldn't want an engineer to go with them, because the engineer would tell them straight up stuff. And the salesmen were bending it our way. They weren't lying, but they were presenting the best of our side.
Yeah.
They didn't like for the engineers to go with them to talk to a customer.
Yeah.
Engineers tend to be different kind of people, and I've noticed it. They tend to be quiet, sit there and do their own work,
Mm-hmm.
and present it. They don't particularly like to write about it, but that's important, because if you do something and you don't write about it, who's going to know? Okay. I didn't like to write, but I found out at some point in my career, I realized how important it was to write down how things work or supposed to work. And now I write up a lib or an explanation as to how something is to work. I sit there and think now, I pretend like I'm dumb. It's like, what? Oh yeah, I was going to say, but they don't know that. And I'm sure you've bought things and read the instructions, and with stuff missing from the instructions.
Mm-hmm.
And you get that on the internet too. Here's how to do something. Pieces will be missing.
Mm-hmm.
And you're supposed to know how to fill them in. No, the guy just knows so much about what he was doing, he didn't think he had to explain that detail.
Yeah. Sometimes, yeah, I think creators, the makers of some stuff, they sometimes are very sure that other people also will understand the same way how
Mhm.
they understand stuff.
Yeah.
And sometimes we wait for the same reaction of other people as our reaction.
Yeah. It should be obvious to everybody that
Yeah.
this is the best solution to the problem.
Yeah. And how to
But
use
it's
it.
not obvious. You have to sell it.
Yeah. It was also really good insight for me, because I also used to think that it is obvious for everybody how to use it, and it's obvious for everybody that how effective is that solution.
Yeah.
Because I'm more into, I don't know, like I like software. I like to write programs, applications, and sometimes I also be like, I created this software, like I give it to my friend, like check it out, and sometimes he gets the, I mean, he gets the phone or computer, and he don't usually understand what to do first, and I'd be like, but it's obvious how to use it.
That's
And
right.
he's like, no, it's
Yeah.
not.
Yeah. Yeah. That's true.
Yeah.
Yeah.
So innovation often requires a degree of risk taking. Can you discuss a time when you had to take a significant risk in your research or teaching or career, and what was the outcome?
I never really thought of myself as taking risks. I tended to be risk avoidant, as a matter of fact. I did do new things. In other words, we used to make printed circuit boards and with components on them and so on. Well, there came along newer ways to do that. Help bring that into the company and get it used and accepted and so on. And in most of the things that I did, I kind of thought, yeah, I could do. I thought I knew how to do it in general, not all the details, but I don't do anything like take a whole bunch of money and design something and put it on the market. I don't do that kind of thing. That's for entrepreneurs. That's for an entrepreneur to come to me and say, would you design this gadget? And I'll design that gadget. Let him take care of the rest of it.
You design it most efficient way, the best way, usable way.
Yeah.
user-friendly way,
Yeah.
and the rest of it is their task to do. That's amazing. So many many people argue that the true test of technology's values are is a ability. Technology's value is ability to address humanity issues. So, can you talk about the project or idea in your field that has the potential to make a significant positive impact on society?
Well, I think computers and computing still have a long way to go
Mm-hmm.
to make an impact. And the artificial intelligence along with it
Mm.
has a long way to go. I think I don't know if it's computing is still in its infancy or not, but the use of computers is still sort of in its infancy.
Mm-hmm.
It's just getting so that automobiles have 50 or 100 computers inside one automobile.
Mm.
Computers are going to take over the world, in a sense. Okay, I don't mean they're going to be kicking us and throwing us in the gutter and taking over my nice house or anything like that, but
They will be everywhere.
yeah.
Yeah. I guess they will improve our life. I hope that it's for the best. I hope that the life of humanity will quality of life will get improved,
Yes.
and the problems which you've mentioned above will be somehow solved.
Yeah.
I don't know, using AI or
A lot of
social
potential
media.
to solve problems inside this country and outside this country as well.
Yes.
Okay. A lot of countries are a lot of people in this world are poor. Why are they poor? Well, probably two reasons. One is they just don't have the means to do any better. They have 1 acre of land and that's all they have, and they can't get any more, and they grow the crops they can and they sell them.
Mm-hmm.
Computers and AI can help, if it's applied right, can help them to figure out how to get twice as much out of that acre, or 3 times as much out of that acre. The other reason people are poor, and I think in this country, lazy.
Laziness.
Yeah.
Yeah.
The federal government, if you don't work at all, I don't know what the numbers are, but you can get aid from the government on the order of $30,000 or $40,000 a year. You can live okay on that. You're not going to have a grand lifestyle, but you're going to live okay on that. I don't want to work. And I'll give you another philosophy thing. the black population were originally brought over here as slaves. Not all of them. A lot of them came later, but the ones who were originally brought over here as slaves, they were forced to work. The only thing they wanted was not to work, because they were forced to work. And when they were freed, guess what? They still didn't want to work, even for themselves, a lot of them. A lot of them did. And I think that's part of what's contributing to at least that sector of our population. I mean, if you were forced to do something all your life, and then all of a sudden you were no longer forced to do it, you probably wouldn't want to do it. No matter what it is.
Yeah.
I'm going to have to eat supper here pretty soon and go to class.
Yeah, I think we have just one more ending question about reflecting on your own path. What advice would you give someone just starting their career path on journey in electrical engineering, and especially in an area so heavily influenced by rapid technological changes and AI advancements? But what advice would you give to these young?
You can get, as an electrical engineer or electrical computer engineer, software engineer, you can get into all kinds of different things. You can get into the medical field, the automotive field. I mean, two quite diverse fields. So what you get in a 4-year degree, and I try to tell my students this sometimes, you're not being educated for a job. You're being educated in general to be able to take a number of different kinds of jobs and know enough about it to get started. You take one whole course in electronics, you go into a company to do electronics. Oh, one whole course, and that's it. Then you get into the company. Well, wait a minute. Am I going to design electronics that send radio waves out and signals out? Or am I going to design electronics that cause things to move around? Different kinds of electronics. So eventually you'll get, hopefully, you will find something that interests you. And you will also find that all the other things you've learned occasionally help you. Okay? The other thing you're learning is how to learn. Okay? And in this field, it changes so fast. You have to keep learning. I came here. I studied computers in college. I had to start over with microprocessors. I started over. And then I got into microcontrollers. I had to start from scratch. Yeah, I had a background that allowed me to start from scratch.
Yeah. I get it. To study more, and you have to keep studying, you have to keep improving, you have to keep learning, and I think it's an essential thing in the field of engineering, in the field of software engineering, in the field of computer science, in
Yeah.
the field of AI.
Yes.
And
They are still changing rapidly. Mechanical engineering, yes, it's changing, not as rapid.
Thanks so much, Professor. It was really productive and really good conversation with you.
Well, I hope it's useful to some of your friends and acquaintances back in Uzbekistan.
Of course, it is.
Yeah,
It is.
that'd be great.
Thank you.